Hello, hello, hello. Welcome everyone. Sorry for being a bit late here. I don't know what I was doing. I was I was configuring OBS. I'm trying to do the streaming stuff. I'm still not a super pro OBS user. I hope everyone's doing well. I can see I have cool. I'm having a good hair day here. Yeah, so what's up? So I'm super excited to get back to streaming a little bit. It's always a lot of fun. I got I'm trying to do something a little bit different this week. I'm going to be trying to, rather than just working on CRISPR Crunch, which we're still trying to get out there on time, That's my main focus still these days, getting CRISPR Crunch working. We have it now on iPhone and Android apps that are building, but there's, of course, bugs, because there's always bugs and, little things here and there to fix up. But rather than trying to do that this week, because, it's not probably the most interesting stream, thought it'd be fun if it was more like a challenge format where I give myself something kind of difficult to do in a short period of time. And the idea we came up with is a little coding challenge where we make a game. So the idea will be to try to make a game in under an hour each time. This is really inspired by a good friend of mine up in Paris. Jonathan Giroux introduced me to this thing called the 1 hour game jam. Hold on, I'm just going to turn down the music a tiny bit because it's blowing out my ears. And then I got to introduce the music also, but I'll do it in a minute. If you've never heard of the 1 hour game jam, it's super cool. It's well, you probably know what a game jam is. It's something where you make a game in a short amount of time. Usually it's like a weekend. Sometimes it can be longer. It might be a week. And sometimes they're online, sometimes in person. The format we really like is when they're in person. We're actually organizing one in Perpignan in southern France in not too long. We're trying to find the date now, but it'll be sometime this spring to early summer, as soon as we can find a date where everyone's free. And what's cool about this is Jonathan, sorry, long way around to say, he introduced me to this thing of making a game in an hour, which is really, really hard. So there's this thing called the 1 hour game jam, and anyway, he got me into that, so I thought that'd be kind of fun. To do that live on stream, it's kind of cool. Now, here I'm not jamming. I'm not going to be coming up with a whole new idea, I don't think. It's mostly going to be, at least at the beginning, I was thinking trying to kind of start with like the most basic games, like the games that are kind of like old classics, and maybe kind of working our way up, to something a bit more sophisticated as I gain a little confidence. But it's good for everyone to know that, it's a real challenge. I'm not 100% sure I'm going to succeed. So, there you go. I'm putting it out there. I'm going to try my best. It's going to be fun. Should be a fun time no matter what. I may or may not finish within an hour, and we'll see. Okay, before I say a bit more, I wanted to introduce the music this week is coming from Pixelizer, who's a really cool composer in Montpellier, so also southern France. And thanks very much to him for giving us the right to use his music. I'm going to post right away a link to his music in the chat if I can find it. There we go. So thank you so much. It's actually kind of fun. I have to be totally honest with you. I didn't know his music until about a few hours ago, and he wrote an email around saying that he was a sound designer and he's interested in working on games. So I said, hey, I'm going to be streaming. Maybe I can show your music live. And he said yes. So that's cool. So thank you very much to him. So we're going to be discovering his cool music at the same time. There's a lot of good electronic stuff in there. There's some synthwave. There's some chiptune. And a lot of kind of that old school 80s sound, kind of retro 80s synthy stuff, which I love. So is happy to play for that. And if you're interested, please check him out on YouTube. Pixelizer is his name, and the link is in the chat. All right, so let's get cracking, shall we? So this is the game. Wait, you can't see. Oh, this whole time you can't see the screen. I'm annoyed myself. Sorry. Here is his. Very sorry about that. Here is his YouTube. Pixelizer is his name. Please check it out, and I put the comment in the chat. All right, so what are we going to be building this week? I thought we'd start with, when you think origins of video games, what do you think of? You probably think of Pong. Maybe you think of Asteroids, which came earlier, which was called originally, or maybe you think of Space War. Actually, sorry, Space War was the earlier one. Maybe you think of that. There are, of course, a few other video games that can enter into early video game history, but I think Pong is probably one of the first ones you think of, right? So Pong, you got a paddle that moves across the screen, you have a ball that bounces, and it's a two-player game, and you're trying to beat the other player. This was the game that really took off on Atari back in the good old days, and kind of set off a whole, kind of like both the beginning of arcade history, and it's also really linked to the beginning of console history because it was a home console game with Atari. So that's cool. So I thought it'd be a fun place to start. And we're going to be using my own game engine called Booyah, which is a game engine we developed here at Play Curious. Everything is in TypeScript, and it all works for the web, although you can also get to work on mobile or on PC by embedding a web browser in your application. My goal for today is to make Pong in Booyah in under an hour. So let's get that countdown timer going. I was just searching countdown timer, and this is what comes up for some reason, is this list where you have a timer with different themes. I wanted something kind of simple, maybe just text. Weeks, days, hours. No, I don't need anything nearly as complicated. I just want 1 hour. Let's see, does that work? Crank countdown. Well, this is way too complicated. 9 hours? No, not at all. That's not at all. All right, that sucks. Okay, let's get another countdown timer. If anyone in the chat has a countdown timer they'd like to suggest, let me know. Set timer. Okay, here we go. 1 hour. Stop timer. Okay, time to make Pong. Countdown. All right, here we go. So I'm going to get this in the corner here. So you get that going. 59 minutes to go to make Pong. Oh no, I don't think we need a really full screen. I'm not going to do I'm not going to do any work. All right, let's see if I can stick that in the corner there somehow. Maybe in the lower right. I don't know. I have to find a place I can put that. Anyway, yeah, I'll put it over here. All right. Okay. Can I see it if I go like this? It'd be cool. You know what? I think if I was a better streamer, I could probably configure OBS to like have that overlaid or something. We got a comment in the chat. I just use a timer on my phone. Yeah, it's true. And I just realized that now, in fact, I put in the lower right, but of course the lower right is, you can't see. So that really doesn't work. I think I need some kind of fancy overlay stuff, but I can't, I don't know how that works. That sucks too. No matter what I do, it sucks. Wait, I got an idea. What if I go like this, I go like that, and I put it down here? Okay, this is really, you can see this is not super sophisticated. But it works, right? You can see the timer. Okay, that's what we're going for. All right. Okay, that's enough. We lost now 2.5 minutes doing that, or 1.5 minutes. Let me see what I got. So I cheated a tiny bit for the very first one because I wanted to get kind of a new version of Booyah going. So I have a new version of Booyah I'm working on. I kind of tried to strip out everything that I've kind of accumulated as cruft in different games, and I'm trying to make a new version. So actually there's stuff that I'm just changing now, and I may have broken stuff and it might not work. So if that happens, excuse, I'll have to say it's gonna take me a bit longer. That's why also first one might not be like a super high performance, and hopefully the next ones will get a bit better. Okay, so I started with something like this just to kind of give like a startup project. I have a black screen, and I have a bunch of lines, a bunch of boxes that are being created. Okay, just to kind of get like something going there. So if I take out the black boxes, like this, I take out the green boxes. Sorry. You'll see I basically have a black screen. And my goal now is to make Pong. Okay. So I'm thinking I'm going to start with a ball that's going to jump around the screen, right? And as it jumps around the screen, it's going to bounce. And that's what I was thinking. Maybe it's a good place to start. And then after that, we can add the paddle and other stuff like that. All right, let's do this. Oh, I was going to eat M&Ms, and now I'm thinking, of course, that's going to not great for streaming either. So I'll wait in between the breaks. All right, let's do this. Let's get that little ball going. So I'm gonna make a ball class ball extends chip dot. Oh yeah, I'm sorry. I used to call them entities. Now I'm calling them chips. I changed the name. So like I said, I'm gonna kind of have to get used to this. So the ball is going to have a starting position, right? And a starting direction and a velocity. We could probably compress them into both. Okay, so for all these things, I'm going to have a, I'm going to make a little interface for, so this one I'm doing, sorry, important, I'm going to do this just using the Canvas API, which is a really basic API for the web. And you just kind of draw lines. I'm not going to use Pixie.js or WebGL or anything sophisticated. I'm doing like something really basic to kind of show how you can use Booyah with anything. So I don't have anything here. I don't have any math libraries. I don't have any physics libraries. Got nothing. So I'm going to be doing a lot of stuff by hand. So I'm just going to make myself a little point. Declare. Oh, sorry. Interface point. And the point is going to be x and y, which are numbers. Okay. Yep. So what I'm going to do here is the starting position is going to be a point, and the velocity is going to be a number. And it's going to have a direction. I think I'm going to break out the two. Normally, you could, of course, put them together, but I'm going to break them out. So you're going to have the direction, which would be a angle, and then the velocity, that would be a number. So it's like the speed. So the direction, which is going to be, I'll just call it the angle, actually. Angle, which is the number also, and that's going to be in radians. I'm going to use radians rather than degrees because all the JavaScript libraries work in radians by default, so it's a little bit easier. Even though it's easier to read degrees than is radians, at least here, it's easier to kind of understand to use math libraries when it's all radians. All right, so let's do something where we give it all this information. So let's make a constructor. And in the constructor, we'll say the, oh wait, here I actually have the position. We'll have the, we'll give it a, maybe, well, actually, you know what? I'll just keep, I won't, later on I think we'll make it so we can give it a position and a direction, but maybe I'll just, by default, to keep it simple, I'll just say when we set up, we'll always kind of start the same thing. So on setup, no, I used to call it on setup. Now I'm calling it on activate. Still getting used to that. Let's say this dot position up equals equals maybe halfway through the screen. So right now I made the thing 800 by 800 pixels. So I'll just do that. I'll just do it halfway through, right? So size dot, let's call it screen size. Let's rename this baby. Okay, screen size dot x over 2, and this dot position. Okay, equals screen x is screen size dot x over 2, and the y is screen size dot y over 2. Okay, maybe the angle we'll make random. Math.random, which returns a number between 0 and 1, times the, let's see, all the way around a circle is 2 pi, right? So math dot pi, or do we have 2 pi already directly? No, we don't. Sometimes, some libraries you do, but here you don't, so. Okay, so basically choose a random angle and a random direction, and the velocity we'll just set to, I don't know, whatever, 1, I guess, by default. We'll see. So that'll be 1 pixel per a certain amount of time. Per millisecond, maybe? Something like that. We'll see. I should probably figure out what that is. All right, and then we'll probably have some function that draws it, right? This dot draw. Okay. When we draw, we are going to do what? We're going to draw directly on the canvas. I'm gonna change the way this works in a minute, but just to get it really simple, I'm just going to do that protected on tick. So this is the function that's called every tick of the game. So every frame, typically 60 frames per second on most web browsers, but it depends. Sometimes this can get much higher. Actually, you get up to 120, 140. So that's why we're going to use a trick to make it work with the elapsed time. But just to make it really simple, let's just draw something on the screen. And later on with the tick, I'll also move it, but I'm not going to do that now. And we're going to draw. So protected draw void. What are we going to do? We're going to take the canvas, which I have up here already. I have this context, but I'll pass this through later. Context dot. So maybe like fill style equals white. This is going to be, I think, black and white to kind of old school. We'll see with the colors later on. And then we'll say context dot draw circle, right? Do we not have circle or fill circle? We can't do a circle. That sucks. All right, let's look up. How do you do a circle in web canvas in web canvas API circle? Oh, you need arc. Okay. Drawing a full circle. Of course, it's the example because it's kind of the thing that you would expect to be able to do. Let's just grab that from there. Yep. So what they do is fill. So arc gives what? Arc is, I think it's X and Y of the center. So that's this dot position dot X, this dot position dot Y, 0, 2 times math by. Yeah, that looks right. How come it does not like it though? Expected 5 to 6 arguments, but only got 4. What am I missing? X, Y. Oh, the radius. The radius is important. How big is this ball? I don't know. Maybe let me just make a constant here. Let's say ball size equals, or ball radius actually would be, I don't know, maybe 5 pixels wide. So we'll give it here the ball radius. Hey, Chaotic Barbarian, welcome. Welcome to the chat. Sorry for ignoring you up until now. I need a little thing that appears on the screen when people have say something in the chat. Okay, so what do we get? We should get a ball in the middle screen. We don't because I'm not actually sure why we don't. I was about to say, of course I know why, but actually I don't know why. It could be something like you need to like say end path or something like that. Begin, because you have begin path. There's no path, close path. Still not. Okay, what am I doing wrong? Oh, because I never gave it to the game engine. Okay, yeah, that makes sense. Yay! We have a ball! That works. Okay. Right, it's kind of small, and it's not particularly elegant, but it totally works. Okay, now let's make this baby move. So to make it move, well, every tick we're going to give it, we're going to move it along its ankle, right? So there's a little trigonometry involved, and normally I would like draw this out on a piece of paper or a whiteboard, I think, but I don't have a great way to like draw, or do I? Maybe I could do like, what's that thing called? The online tool. Draw.io. I think that's it, right? I know there's different kinds of drawing thingies. So, quick lesson in trigonometry. Up. We have a ball. We want to move it on some angle, right? As usual, you have axes, if you remember a little bit of math from high school. Video games are basically, I mean, the kind of video games I make, which are 2D for the time being, are actually mostly like high school math. So here you have the x angle, the x directing, and the y. Okay, now this might seem weird. I thought y went upwards. Yes, it does. In math class, it goes up, and on most drawing APIs, at least in the that I know, it goes down. I don't know why that is. So you can reverse it if you want. But anyway, this is just the way it typically works. So x to the left, to the right. I mean, from left to right. Y from top to bottom. And you're going to have some kind of angle, right? And that angle is, if I could do a little circle type. Yeah, I have no idea. Sorry, I don't draw usually using these things. Where do you have a drill drawing guy? Or like a circle guy? You can't. There must be like some can you like this? Like from here. Whoa, this is some crazy. Alright, I don't think that's it. I just wanted a little thing that turns. I can't do that. Can I do? Text, rhombus, freeform. Manleve. I think that's it. Yay. Okay. That's your angle, right? A. Okay. Why is it drawing instead of letting me write text? Do I have to select something else? Psh, stupid. Should rename the stream to Jesse tries to figure out how diagrams.net works. Okay, so that's your angle, right? So your angle goes like this, goes whoop in this direction. And the trick is, when you want to translate this into x and y positions, well, you use a little bit of trigonometry. So the basic trigonometry equations are the way in so your delta x equals cosinus of oh wait, I'm blanking on it. Delta x equals cosinus of the angle equals x over the hypotenuse. I'm gonna have a longer diagram than this. And your sine of the angle equals y over the hypotenuse. So your hypotenuse here is this little line that's going to go doop to here of your. I don't know how to draw. If that makes sense. I'm not sure this is actually helpful. Okay, and this allows you to figure out to translate from an angle. So to go the other way around, if you have an angle and you want to figure out what the x is, well, you say x is cosinus of a over the hypotenuse. So let's go back to here and we can do that. So we're going to say this dot delta. Oh no, sorry, just say delta x equals angle wait, sinus and cosinus. I'm doing this all the time over h. Yeah, so since we have an angle of 1, no, I'm trying to. No, I'm silly. It's just the cosinus of a. So math dot cosinus of the angle and const delta y equals math dot sine of the angle, and we can there say this dot position dot x plus equals. Actually, I'm just gonna simplify it like that. Yep. this dot position dot y plus equals the sine of the angle, and the angle, of course, at this dot angle. And now we draw. So let's see what happens now. Okay, cool. So now we have, each time it's going a different direction, right? Kind of slowly. And you'll notice that it's just sort of, it's never erasing anything. So it's actually making a line all the time. So this obviously isn't great, right? We want it to refresh. So what we have to do is we have to clear the canvas every time we draw. So since I have everything in the ball class, I'm going to do it here. Later on, we'll have to change this. How does that work? I think it's context.clear, rect 0, 0. The width is screen size.x and screen size.y. That's not working because when it's clearing it to white. We want it to clear it to black. Okay, let me change that. Oh yeah, so you know what I'm gonna do? I'm gonna just, rather than clearing it, I'm just gonna fill it black every time. So I just set the, so I have to set the fill style to black. Okay, so I set the fill style to black. Yeah, it's kind of working. It's kind of slow. Huh? It's kind of slow. Let's give me, what is it, twice as fast? No, that's the size. Let's do the ball speed. Ball speed equals, let's say, 3 times as fast as that. So we'll say, oh, right. I have to do the cosine times the speed. Sorry, this velocity. That's the part I was missing. I knew I was missing something. Okay, so we have a ball that's a little faster. Now, obviously, this is not fantastic because it's just kind of going, huh? It's going and it's never bouncing. Let's also make it a bit bigger while we're at it so you can see it a bit better on the screen. Hopefully can you see it like that? Is that good? I hope so. All right, so now we got to move it on the screen. Let's make it bounce. Okay, so the trick of bouncing, of course, is that when you want to reach the end, you want it to bounce. In our case, this is actually pretty easy. So right, we have this kind of field, and we want the ball to. Actually, no, I'll just draw it as separate lines. We're gonna have the ball come up, right? It's gonna hit here, and then we want it to bounce off the other direction at an angle. And in general, we want this angle to be the same as the other angle. So in theory, this could actually kind of be sort of arbitrarily complicated. Like if you have this line that's turned, it's actually a little bit tricky. But in our case, it's going to be super easy because we're just going to cheat. And we know that we're only bouncing across lines that are either the vertical or the horizontal. So this makes it super easy. What we can do is just say, basically, if you hit the top wall, well, you just flip your y direction of your vector, of your angle. Sorry. You're going to rotate your angle if you hit the top. If you hit the X, you rotate the other way. So every time you're going to just rotate, which makes this way simpler than doing something else. So let's see. Then it'd be way simpler than if we had the whole screen that shifted or something like that. Or if you're bouncing off angles at weird corners, it would be more complicated. So let's handle that. We say. So if this dot position dot x is less than, well, let's just do it with the y first also, is less than 0, then we go, and in this case, we actually have to flip the angle. Oh yeah, because I didn't do this with a vector, I did it with an angle, so what does that mean? Well, let's do the bottom wall. Let's see. Is it plus? It's not 180. Oh, actually, it's a little trickier than I thought, because if we're going to the right, we're rotating plus 90 degrees. But the same thing in the other direction. If we're going to from right to left, we're actually going to be going, the angle is going to be minus 90 degrees. So it's actually not quite as easy as I thought it was going to be. This is actually way easier if you just separate the x and the y components. So I wonder if I'm just going to cheat. Well, I guess I could. Is it always 90 degrees? Also, I'm not sure actually. I said 90 degrees, but actually, if you're here... Yeah, actually, if you're coming from a tighter angle, it's not going to be plus 90. I think you have to take the entire angle, subtract out twice of what angle you are compared to 0. Ooh, it's complicated. Okay. In the interest, I only have 35 minutes left, and I haven't gotten very far. I'm going to cheat here and just break it out to a vector first. So I'm going to say if position less than y, then this dot so actually, you know what I'm going to do it like this. Delta y times equals 1 minus 1, so flip it from negative to positive. And then again, math is hard. Yes, it is hard. Well, plus, you know, I actually don't like it when I have this little, like, pressure, because normally I would take the time to try to, like, work this out. Is this, like, I've done this before, actually, a long time ago, and not Pong, but other bouncing things, and I know it's totally possible, and I could figure it out with the angle, but actually it's weird. There's something about having this time pressure thing, like, 30 minutes left, I'm like, so it actually, like, my head gets all, like, panicky, and I have trouble doing math, so I'm just gonna rely on really simple things. So delta y minus equals 1, and we have this dot. Then I can re-get the angle out of that. This is really not the best way to do it, but whatever. I'm cheating. This dot. Angle equals math dot. The cosine of the angle over, oh no, the cosine of the inverse cosine of y over of x over h, so of x, so oh wait, but then no, the tangent a tan A tan 2, we give it the y, which is delta y, and delta x. All right. All right, let's see if that works in the case where y goes up. So we'll have to give it an angle of, rather than giving it a random angle, let's give it like, say minus math dot pi over 2. I think that's up normally. Well, not over 2 directly. Let's say over, say times 0.75 or something like that. Yeah, I think that should be up. So it should at least bounce off of the top wall, and maybe not, and it won't do the other ones. Oh man, I'm heading just, okay, we can't see it. That's a crappy angle. Times, let's see, 0.15 or something. No, that's not the angle either. Oh, that's why radians are annoying. It's math pi over 4 would be the directly angle, so minus math pi over 4. It gives that angle. That's so annoying. Maybe times 3 over 4? Oh, God damn it. Divided by 6. Come on. Oh man, I hate radians. Okay, come on. Maybe we just need formulas to do things in degrees, and we can do this like a proper thing. Oh, you know what? I know what we'll do. Rather than messing with the angle, let's just move it up a lot. Rather than starting in the middle, we'll start it like up really top, close to the top. We'll say screen size, say the Y is like, 100 pixels from the top or something like that. Yes. Hey, it bounced off the top one. Okay, that's cool. So this general approach works. Again, this is poor math on my end. This could be way better. Else if this position, okay. Okay, so if that happens, then you have to check the other ones. So if position is greater than, I guess this probably can't happen, both of these at once. So so we're from the bottom wall. So if we're bigger than the bottom wall, then we set it to be at the bottom wall, and we reverse again. So to test this, let's put it near. Oh, actually, let's just be super optimistic. We're just going to imagine all these things worked, okay? All right, now we do the same for the x. Say if x is less than 0, then we set it to x. Delta x is 0, and the angle is, again, this thing. And if the x is greater than the screen size of x, then we do So you can see this is basically the same formula as before. And a lot of this is kind of the same. I could probably recalculate that. But let's just try it out. Does it bounce off all the walls? Yes, that's what I'm talking about. All right. Sweet. We got a bouncy ball, my friends. We have a bouncy ball. Now, if you're very attentive, you might notice that actually it doesn't bounce off the edges of the wall. It actually goes all the way in. That's because we're checking the center of the ball. We're not checking the edges of the ball. So if you wanted to do this all correct, we could actually check like when it hits minus the radius, so we can do it. So if position y is less than this dot, or just ball radius, and we can fix it like that. And we'll just take into account the ball radius. I don't know if this makes sense. If it doesn't, please ask. If anyone has questions, please ask in the chat, because I'm just gonna, because I'm kind of on a time thing. I'm trying to go as quick as I can and not overly tutorialize. But if you're confused about something, you want me to clear something up, please do ask. I'd be more than happy to answer your questions. Okay, so we got bouncy ball. Okay, so that's, I would say, like half of Pong, right? Which is good because we only have 27 minutes left. So let's do the thing now at the bottom there. What's that thing called? The paddle. All right, let's do the paddle. Okay, so And just really quick, because this is so ugly, I'm just going to, no, whatever. We don't have time. We don't have time to clean this code. I am going to do a little bit of a minimum. I'm going to save my work using Git. Always a good thing to do. Git add, Git status. Do we have? Let's check what I'm adding. It all looks good. Git commit. Bouncing ball. Okay, I got a bouncing ball. Now let's get this. Oh yeah, we can now get back to a random angle. And we can put this back into the middle. And let's make this ball a little faster. Bam. Okay, that's cool. That's maybe a little too fast, but whatever. That's not so bad. Okay, so now we're going to need a paddle. So to get the paddle to work, we're going to have to extend this a little bit. So far we've done all the work using the ball class, like everything in one class, but that's actually not the best way to do it. Like we want to have multiple entities. And what we are calling now chips using Booyah. So to get that to work, we're going to have this game chip, and the game chip is going to contain the ball chips. Let's first do that before we do anything else. Which means it is going to have a it's going to have a protected on activate. So what's the code that's called it first? And it's going to call this this dot draw. It's going to have a draw too. They're almost all going to have draw functions. And its draw is actually going to do the clearing thing. We're going to take that out of here and put it into here. And then its tick class is also going to draw. Basically, it's drawing all the time. All right. And it's going to say, so now we get a black screen because it has to contain a ball. So it's going to contain one here. So it's going to say this. It's going to have a ball. Private attribute ball. This is the ball. Can people see my screen okay? I don't know if the text is big enough. I'll blow it up a little bit here. The ball on active. So on activate, we're going to first create the ball. This dot ball equals new ball. Oops. Not a battle. And it's going to activate it. This dot activate child chip is, and then I add this dot ball underscore ball. Okay, cool. So this looks exactly the same as before, but I'm actually doing something a little different. It's actually in this first chip here, the game chip. So you can't see my pointing at the screen. Doesn't work. Here it's actually doing the clearing, and here it's doing the bouncing. So two different things. Oh no! Don't ask ChatGPT. What a cheat. Of course you can. Of course you can. But do you understand how it works? Huh? Can you understand how it works? That's the important thing. I'm sure you could ask ChatGPT to explain it. Can you ask ChatGPT to do a live stream of someone making Pong in an hour? Huh? Can you do that? I don't know. Maybe you can, actually. We're all headed to destruction, my friends. We're all headed to destruction once the robots come. But we still have 22 minutes left to prove that humans can still do something. We can still make Pong. Maybe not as quickly as robots, but in a more understandable way. And using Booyah, huh? All right. So where was I? So now we need a little paddle. Let's make the paddle. Const paddle. No, not const. Class paddle. Extends entity dot. Oh no, not entity chip. Chip base duck. And we can say class. So it's going to have pretty much a similar thing. We're not going to have a velocity. We're just going to have a position. That's it. Right? The paddle just has a position. It moves around. At the beginning, I think we're just always going to put it. Let's just do one paddle for the time being on the bottom. Okay, and then we'll extend it. We'll say, so in protected on activate, we are going to say this dot position equals, let's see, well, it's the x in the middle, screen size dot x over 2. Again, we'll do the middle of the rectangle. And it's near the bottom, so screen size dot y minus, I don't know, 10 pixels off the bottom or something like that. Maybe that makes sense. And then we'll say draw. Sorry. We don't have a draw yet, but we will do that. Private draw. So I think we're a similar kind of thing. We'll make it white, and then we're going to do a rectangle. Sorry. We don't need the begin path thing. I think we can just do draw rect, I think, or fill rect. Fill rect, x and y. So, oh yeah, we need a size. So, paddle size is a point, and it is x, I don't know, 100 pixels? Y, 10 pixels. I'm just making stuff up, and we'll figure it out later. So fill rect this dot position dot x minus paddle size dot x over 2. So just basically saying start halfway to the left, and we need the y coordinate, which is the same thing. When y, this dot position dot y minus paddle size dot y over 2, and then we need our width, which is paddle size dot x, and our height, which is paddle size dot y. And that's a little rectangle, and we don't see it yet because we need to add it. So we'll add it again to our game. I'm loving this music. Let me do a quick, as soon as I get the paddle work, I'm going to do a quick shout out to the music. Oops. What did I just do? What did I just do? I meant to do copy, paste, paddle, new paddle, activate the paddle, deck. No, not, it's not, oh yeah. Come on. Come on. I don't see it. I don't see the paddle. Where is it? But I did activate it. Oh yeah, because you have to draw it every frame with this thing. All right. Okay. Cool. All right. Right. So it's not going to bounce off the paddle or anything, but just quick shout out to the music. Little break as I eat a little M&Ms. Who are not sponsoring this podcast. They should, though. I mean, this podcast. I wish I was doing a podcast. I listen to too many podcasts, so that's what I think of. They're not sponsoring this stream, although they totally should. M&Ms. But I'm listening to really cool music by Pixelizer. I gave the little story up top. It's a guy I just discovered. He's really cool, though. I don't know him very well at all, and he sent me his link and said, hey, I make music. It would be fun to add music to a game. And I said, hey, that'd be cool. I'm doing a stream later. Could I put you on? He said, no problem. So here we go. Once again, Pixelizer. I put his stuff up earlier in the chat. I'll put it in again if you're interested. He has a bunch of cool synthwave stuff, some remixes from video game music, and a bunch of different things. I'm going to take a quick M&M break, and I'll do the paddle. And I'm back with the coding challenge, making a game in under an hour. I'm making Pong. And let's see, how am I doing? I got so far a bouncing ball and a paddle that doesn't move. I don't know if that's good or bad. I'm only 15 minutes left. This is actually a lot of pressure. I thought I'd be a lot farther. To be honest with you, where I am now, I thought I'd be in after about 20 minutes. So I'm way behind what I was thinking. Let's hurry up. Let's hurry up. Let's try to do it, finish it up. So we have a paddle. There's two things we have to do. We have to be able to move it, and we also have to be able to we have to move it, and it has to bounce, right? Those two things. So I don't know which one to do first. Maybe we'll just do the let's do the moving. I think I'm gonna use here something that I wrote a long time ago for Booyah called input that should allow you to sorry, I'm looking at the code here to see if it's actually usable. The problem is that I haven't updated it to the new version of Booyah, and so I don't know if it is going to work or not for what I'm doing. I think I'm just gonna because I included in this thing like a gamepad and everything, but I think that's not gonna work. I could use the mouse otherwise. That could be probably a good way to do it. I could say the mouse as it with the mouse, but then I can't do two different players. Okay, so I think I will do the keyboard, but I'm gonna not use this code. I'm gonna rewrite it on my own. Sure, that sounds like a good idea. Okay, so I'm gonna write a different class that's gonna move the paddle. Paddle mover, I guess, or paddle input. Extends entity dot. No. I keep saying entity. Chip base. Okay. We're gonna give it the paddle to move because it has to know which one to move. In its activate, it's going to start listening in on those things. So it's going to say. So here I'm going to cheat. I actually have access here to the global thing, so I can just say canvas dot add entity listener key down, and we say this dot on key down. Event, and we're going to do the same for key up. Key up, event. Okay. Of course, we need these methods. Oh man, I'm running out of time. Event, which is a keyboard event. Okay, so it's going to look at event.key. I think it's key I used. Is that what I use? No, event.code. Event.code. Right now I'm just going to print this out. Console.log down event.code. Let's see what oops. Event.code. Okay, so it's arrow left, arrow right, arrow up, arrow down. Okay, so We're going to use arrow left and arrow right. Okay, we're going to say if. So it's going to have private left down is a Boolean. And private right down is a Boolean. If event.code equals arrow left, then left down equals true. Otherwise, if it's arrow right, then right down equals true. And I'm writing that poorly. And I'll do the same thing here. And here I set it noun. And basically every time it is on its on tick, it's going to check if things are on, and if so, it's going to move the paddle. So if this dot left down, then it's going to call this dot paddle move left. Else, if the right down, move right. We don't have these methods yet. I need to do that. I go over to paddle, move left, move right. No, it's not private, it's public. Move left. This dot position dot x minus equals the paddle speed, which we need to generate. Maybe 5 pixels at a time. And move right would be the same, but to the right. And if I do that, it can't find it, the paddle, because I probably didn't give it to it when I have to give it here this dot paddle. And which means I never took it in the constructor. So I'm going fast, how much time left? Read only paddle is a paddle. Oh no, not there. It's in the paddle input. Okay. The left works, not the right. What's up with that? Not the right. If it goes up right down equals true. Oh, okay. Now I got a paddle that moves. Now the problem now is the bouncing, right? Also, we would need 2 paddles, right? Okay. So I'm clearly not going to make this in the 7 minutes left. That's good. I think what I'm going to try to do is just to get the bouncing to work. Already, I'll be kind of happy, and I'm going to call it a half victory if I get that far. Let's see. So let's move it off a little bit from the top there. Oops, no, it's not that I wanted. I wanted to just move it off the bottom a little bit so we can see it. Okay. Right, so here it should bounce, but it's not, right? Okay, so what I'm going to do there is the ball needs to know about the paddle, or the paddle needs to know about the ball. I think it's probably the ball knows about the paddle. Probably makes more sense. So we're going to tell it about the paddle. And it's going to check if the ball collides. So how are we going to do this? The ball has to check about... Yeah. The ball knows about the paddle, so what we're going to do is the ball is going to take the paddle in its... here. There's better ways to do this, but I don't have time. So in my collision code, I have to check here if I hit the paddle. So this is generally the same idea as you do. These are using line intersections. And I'm going to cheat because I know the ball's heading down. I'm just going to see if we go... Oh yeah, I know how we do it. I'm going to stop talking and just do it. But this is going to be very brittle code. It's just working in the case of, you know, what I'm doing here. So if we're going down, if this dot angle is, no, this dot angle is greater than, actually, I have to check if we're going down. Oh yeah. This dot position dot y is less than this dot paddle dot position dot y, and this dot position I know, but I already did it. I kind of need the old position. Actually, if this dot position dot y minus delta y is less than that, and this position dot y is greater than this dot paddle dot position dot y, and this dot position dot x is less than this dot paddle, this dot paddle position dot x minus the width paddle size dot x over 2, and that and the same thing on the y. Oh no, it's greater than that, sorry. Less than, and then we're gonna do a reverse of the x, reverse of the y, very similar to this one. This dot equals this dot paddle dot position dot y. So let's see if that works. Come on, come on, come on. Oh, kind of worked. It looked ugly. I think because it's hitting the bottom. Oh yeah, because I'm not checking the radius. I'm not checking the radius, but still though, the idea kind of works. So I'm definitely not going to get farther than I am. I think at the 1 minute left, I could adjust that one little bit here. And making that better. I got it. This code is really ugly, but basically to explain it, what I'm trying to do is to say, if we're about to go through the y. So this is the amount that we are for down here. If we're going to go through it, we're going to go through the paddle, and the x value is between the left side of the paddle and the right side of the paddle, then do that little reversing logic that we did before. And that's what would happen. And we could make it a little bit better by adjusting to the paddle position minus the ball radius. And we can make that a little clearer by saying old position, const old position equals this dot position dot x. Just cloning the position here. And we could make here if this dot, no, so if old position dot y is less than paddle position of y, and old position dot y is less than, right, so minus the ball radius and the old position of y. And time's up, time's up, time's up. Man, I thought I'd get so much farther. Alright, well, I tried. It's my first of these. Hopefully I'm going to get better with this. As you can see, Pong, it looks really simple, right? When you think about Pong, you're like, oh, there's not much to it, right? It's one of the first video games ever made. I'm sure you could code it quickly. In my mind, like I said, I honestly thought I was going to be done after like 20 minutes, and I was going to have a lot of time, and I was going to like, maybe I'd make a whole new game, or I'd add like 6 different paddles or 20 balls or do something kind of crazy. But as you can see, I'm so far from that. Oh, it's tough. But it was still fun. And hopefully you can see where I'd go from there, right? It's not very hard to imagine where you go from this. Once you have one paddle that moves, right, and you can check collisions properly, which I didn't really do very well, you would then probably do the same thing with the second paddle, right? And the second paddle, at that place, what I would do is I would have a, I would take this paddle input class that I have here that where I say, right now it just controls a paddle that I give it in the constructor. And what I do is I also say, well, which keyboard keys do you want to listen to? So I would say, okay, well, use the A and the A and the S keys for the top paddle, and I would also give it a position, like a Y position. Say, this was on the top, and then of course I have to recode the collision detection as well, because right now the collision detection is very specific for it kind of going down. You'd have to kind of work for that in both directions. And after that, I think I'm missing the points, right? You would need a point system. So you'd have to have something where every time it went over, you don't bounce on the bottom. Instead of bouncing, you give the player a point for the one who went over. And maybe you'd have a game over when they reached a certain number of points. Thank you, Chaotic Barbarian, for your encouragement. And so I hope that works. I don't know if there's any, if anyone has any last questions or comments, please put them in the chat now. And otherwise, in the meantime, I'd just like to say thank you once again for the excellent music by Pixelizer. It's really cool to listen to some good chiptune and cool synthwave stuff and video game remixes. If you're interested, please do check him out on YouTube. He might be in other places too. I don't know. Like I said, I just discovered him, but I found it really cool. If you're interested in this game framework, Booyah, that I'm working on, cool. Thank you, Tivo. Thank you. Then please check out our website and our GitHub for Booyah. So this is actually a new. Let's see if I can find this. Booyah.com/playcurious/Booyah. You can find out about this game engine. This is a new branch. I'm just working on branch V3. I'm going to be talking to it about it more. I'm going to try to do some cool game conferences a little bit this summer and talk about Booyah. If you're interested in about Play Curious and the kind of things we're doing, please check out playcurious.games, our new website that we're very proud of, and you can find out what we do. Our speciality is actually making games where you discover cool things in science and technology. So we have a game about blockchain. We have a game about CRISPR that we're working on right now called CRISPR Crunch. That's a mobile game. It's coming out pretty soon. So if you're interested, please do subscribe to our mailing list. If you click the nice subscribe button here, you can fill out your name and email, and you will be informed as soon as we have a nice We had a new version for you to test. It is coming very soon indeed. That's what I'm doing when I'm not streaming live, making a fool of myself trying to make games in an hour. That's all I can think of. So thank you very much. Thank you everyone who joined us today. Thank you for Raphael for helping out on the stream. And I think we're going to catch up with me next Thursday with another game. I'll try to do another game. I'll try to finish it this time in under an hour. And Raphael will be streaming science games on every Tuesday. So what he's doing is kind of cool. He takes a different science game each week and streams himself playing it. And sometimes we're even able to get the developer on to give us comments. So that's Raphael on Tuesday with streaming games, and me on Thursdays doing live coding. I think that's all I can think of. So thank you very much for joining us, and have a great day. Bye.